Okay, so I'm on page 597. Page 597. We're starting this whole thing about parabolas. So here's our story problem. Farmer can build this area. Actually, it's a dog trainer, not a farmer. And they want squares on the ends, okay? So you get 100 feet here, but as the squares get bigger on the end, then this piece gets smaller. On the other page, they kind of show a picture of all the different ways you can make it. So they show that, you could have small squares on the end and a long piece here. So you can build all of these different pins. Now, some of these pins don't have very much area in the middle. And then probably this one's got the biggest amount of area. And that's what we're going to find out, is how to figure out which is the best pin. So what I did is I took a look at all the different possibilities. If this square was 0, then this length is 100. If this side were 10, then this length is 80. If this side here and here were 20, then this length is 60. If this side was 40, then this length would be 20. And of course, if this is 50-50, they wouldn't have any middle pin at all for the dogs. Okay, so then we looked at all those points and we graphed it and realized that it had an equation of y equals negative 2x plus 100. Okay, which that makes sense. It's the exact same equation here. Okay, then the domain of the square lengths, these square lengths can be anywhere from 0 to 50, because if it's 50-50, there's no square length. And the area of this rectangle, the length of this rectangle could be anywhere from 0 to 100. Okay, that's our domain and our range. Okay, then we looked at the next page and we said, okay, well, what do we know about this graph? Okay, so we got y equals negative 2x plus 100. That's the length of the pin. We know the slope is negative 2. The y-intercept is 100. It is definitely decreasing because as the squares become bigger, the length becomes smaller. And the x-intercept is 50, 0, because that's where you're going to have both pins be 50-50, and you're not going to have anything left for your rectangle, okay? So then we looked at the area of this darn thing. Well, we know area is length times width, and our pin, when we drew it, looked like this, and we'd have an x by, and this is our 100 minus 2x, and we know that area is just length times width, and we put it on decimals. So I actually put it on decimals to see what it looked like. Okay, so I graphed this on decimals, and I graphed the whole thing. Let me regraph this. That's not the one I want. If I put my, here it is, x times parentheses my 100. Stop that. Stop that. Stop that. 100 minus 2x. I get the area. The area of the dog pin. Okay, so then it's so big I can't see it, so I'm going to go looking for it, and what I'm looking for is the vertex. Okay, it's right there, and I want the vertex. So I tap on that, and I get a point at 25 and 1250. So I'm going to remember that. Okay, so I graphed all of these points, and when it got up to here at 1200, I knew there was something bigger. There's a better pin. So I go up, the graph's getting bigger and bigger, and then it gets smaller. But right here is the best, and that's what we just did, the vertex. Okay, the vertex then has got to be at 25, 1200. So what does that mean? Well, we know that the width is x, okay, and the y is the area. So the best pin to build is one where this is 25 by 25. That's the width, 25 by 25, and then we know that this length has to be 50. Okay, so then the best pin we can make has a size of 1,250, because that's just length times width, which is my 25 times my 50 gives me 1,250. Any other pin is not going to give me the most amount of area. Okay, so we built the pin. That's the best area. The vertex tells me the maximum. Build your fins 25 wide, and we'll get an area of 1,250. Okay. So that's what I had for today. Homework was a worksheet. Come see me if you have any questions, and that's all I got.